Hello, and welcome to Inspire Tokyo. I'm Chris Galucci. The Inspire Tokyo podcast is brought to you by Kikokuhshijo Academy in Tokyo, Japan. On this show, we interview leading figures in science, the arts, education, business, and politics to help young bilingual students learn more about potential career paths for their future. Nowadays, it seems like everybody is talking about artificial intelligence. AI is the latest buzzword, it's all over the news and pop culture. The field of AI, however, is much deeper and broader than most people know, and it has the ability to restructure the way every human on the planet lives. Today on the show, my guest is Azamat Beknazarov. Azamat works as a solutions engineer at Google, based in their Tokyo office. He has been in the IT industry for the past 7 years, working on web development, advertisement technology, and most recently, machine learning, or more accurately, predictive modeling, which is one of the many subfields within AI. Our conversation takes a bird's eye view of machine learning as we discuss what it means when a machine actually learns something. We also get into the nitty-gritty nuts and bolts of exactly how a machine is able to process information just like a human. If you find AI and machine learning fascinating, and you've always wanted to learn more, this show is a great place to start. Hi, Azamat. Thanks for joining us today.
Hey, Chris. Thanks for inviting.
Yeah, my pleasure. So to begin, can you tell us a little bit about your background, perhaps where you grew up, where you went to school, and how you got involved in what you're doing now?
Yeah. So I grew up in a country called Kyrgyzstan in Central Asia. Kyrgyzstan, yeah. It's a tiny country. And then I did my bachelor's there in social sciences in sociology. And then right after that, I decided to come to Japan to do my master's in international relations plus international economics kind of stuff.
Okay.
And then right after graduation, I joined a Japanese company to do some web development, some technical stuff, design-related stuff. And then after that, I got a bit bored, decided to jump into another industry. Joined Google, and then was working around ad tech.
Ad tech?
Ad tech.
That's the technology surrounding
ads.
Okay.
Yeah, online ads, basically. So I was technical consultant, and then was doing building different kind of prototypes for big clients, doing technical consultation. And then from there on, I just moved into data science, bit by bit, server-side programming. And then from this year on, I completely moved into machine learning field.
Wow. So that was a pretty circuitous path.
Kind of, yeah. But it's unconventional a bit.
For sure. If I could take a step back, your studies in Kyrgyzstan, were those in English?
Yeah, so there's a college or university. I think it's university called American University in Central Asia. So there's one university. And I think American University of something is like around the world. I think there's in Bulgaria, there's somewhere in Europe, maybe Latin America, I don't know. So they set up university in Central Asia as well in that country. So I went there for 4 years. And then we did studies in Russian and in English.
Oh, wow.
So, yeah.
So you're trilingual then?
I would say, yeah. And I have my native language, Kyrgyz, so.
Oh, right.
Yeah, that's always big.
Yeah. So the main topic for today is machine learning, and we will get to that soon enough. But I want to talk a little bit about the technical consultation you did for advertisements, because anyone who spends any time on the internet realizes that that's big business. There are a lot of advertisements out there. So specifically, what kind of projects did you work on with that?
So I used to work on dynamic ads.
Okay.
What it is basically based on users' preferences. You would just basically adjust the ads to meet users' basically preferences and expectations.
Okay. And so what kind of preferences?
I don't know, like if you like, for example, rock music or a certain type of clothes or a certain type of device or whatever.
Oh, okay.
And based on that, you might adjust the ads to meet the user's expectation, basically.
I see. And would it also account for things like if I were a male or female, what part of the country I'm living in, or?
It depends. Like if advertisers on their own, they have this kind of data, then we can adjust.
I see.
Yeah.
How many different data points are considered to show before showing the next advertisement?
Depends. They're like very complicated platforms working behind. And there's auction happening in each of the websites. So you see the banners and some other stuff. So for each of those places, there's huge auction happening on the back end. And then within certain milliseconds, the bidding happens and then ad is picked up and then shown to you somewhere around like at a certain point in the earth. So.
Wait, whoa, okay. So when you say bidding, you mean companies are bidding for spaces? They don't actually purchase the space?
So there's different types of ad serving systems.
Okay.
Some of them are like based on auction. Some of them are reserved.
I see.
So some places are reserved, and then one advertiser can advertise for a day or whatever period they basically secure the place.
Right.
And some places are on the auction.
I see.
Yeah.
So there is a lot going on to these ads.
It's crazy complicated system.
Really? When did it become so complicated?
With the advent of, I guess, internet. I mean, since when, I don't know exactly historically, but I guess since maybe early 2000s, mid 2000s, I don't know.
I see. Now, on the back end, the technology-wise, is there any machine learning related to this, or is this just simple algorithms?
Definitely there's machine learning.
Is there? Okay. So this might be a good time to just jump right into this topic now. So I think most people out there have heard of the term AI, artificial intelligence.
Yep.
Not many people may know what machine learning is. Could you give a brief definition of each and maybe talk a bit about how they're different or how they're similar?
Sure. Yeah, one disclaimer, I'm not expert.
Okay.
I'm new to this industry, but what I know, AI basically as a concept started from 1950s, I guess. So general idea behind AI is that basically make computers or machines to think like human beings.
Okay.
Reason like human beings, basically. So it's a very broad term that covers broad range of technologies. And machine learning is kind of a subset of AI.
Okay.
So machine learning, I guess, as a field within computer science, maybe started around 1980s.
Okay, so fairly new.
Yeah, fairly new. So main idea behind machine learning is so you provide certain kind of data to a computer, and instead of programming rule by rule, this happens, then do this.
Right.
Instead of doing that, you just pass the data to machine, and machine will understand the data using different kinds of algorithms and learn on its own.
I see.
Yeah, that's what machine learning is. And that kind of concept, that kind of work and development of algorithms, I guess, started from 1980s.
Right.
And then currently the biggest topic within machine learning as a subset is called deep learning.
Deep learning. Yes. All right.
And deep learning, I guess, became pretty popular since 2010.
2010, oh wow.
Yeah, it's pretty new. But it's been around for a while. I think early 1990s maybe. But most experts kind of say that the technology or like the compute power was not enough to train huge models, like deep learning models with huge data sets.
Right.
And then currently internet server-side technology enables to conduct very large-scale machine learning trainings.
I see.
And then deep learning basically took off from 2010. And then now everyone's doing deep learning.
Got it. So as computing power improves, that allows for this technology to flourish.
That's one thing. Another thing, I guess, is the amount of data we have. The internet.
There's just more of it now.
Yes.
Yeah. Okay, to take a step back about how machine learning works, there are some famous examples out there of computers playing games against other humans. Jeopardy, checkers, Go, chess. Those computers, are they employing machine learning, or are they just working on a set number of algorithms to win the game?
So I'm not confident to say exactly the technical details of these game-playing systems.
Okay.
But from what I've heard is, for example, I think in 1996, was it like the blue
Deep Blue.
Deep Blue won Garry Kasparov on chess, right?
Right.
So from what I've heard, I haven't really fact-checked, but I think the system was basically mostly rule-based. I mean, there was like, of course, piece of machine learning involved in it, but it was like basically brute force, rule-based kind of algorithm to calculate all possible steps on the chess to win the opponent.
Oh, I see. Okay.
So I am not exactly sure about the exact numbers, but on chess, I think there are like around 200 million maybe steps, or like possible ways of moving the pieces around the board. And then machine basically does the calculation and prediction. If you move this one, then what's going to happen, that kind of stuff.
Ah, I see.
But with the deep learning, and then I think the recent play of game of Go, there was like heavily deep learning involved, where machine plays with itself for maybe hundreds or thousands of times, and then each time it improves itself.
I see. And so there is no algorithm per se to improve itself.
There is like definitely like multiple algorithms involved to make the machine to learn and keep the memory of certain like game strategies or something like human beings basically learning.
Right. Wow. Okay. So what would be a good example of something that uses machine learning that touches everyone's lives today, that's already kind of widely used?
Yep. Do you use YouTube?
I do.
YouTube recommendation.
YouTube recommendations?
Yes.
Okay. Can you explain a little bit how that works?
So yeah, when you search on YouTube, you had some kind of recommendations, and there's like ranking algorithms working for you to figure out best possible videos for to meet your query, to meet your search basically.
So it's for searching?
Yes.
And for recommending the following video to show you?
Yes, and when you click start watching, and then you see on the right side different kind of recommended videos, and that's the basically machine learning trying to help you to find the best possible content.
Wow.
Yes, out of like billions of videos.
Yeah, that's pretty impressive.
Yes.
All right.
And another one is, I guess everyone uses Amazon. Not everyone, but most people know the service. So when you're looking for some kind of items, then there's like at the bottom there's like recommendation. Like people are searching for similar things. So that's also basically out of millions of different kinds of product categories, product types, they're extracting most relevant to your search or to the item you're looking for.
I see.
So that's also involving the machine learning.
Are you familiar with Mechanical Turks?
Yes.
Okay. Are Mechanical Turks still used for that kind of work?
So Mechanical Turks, I think, are used mostly in the case where you don't have enough data.
I see.
So they have to label the data. If it's, let's just take a very simple case. Let's say you want to create a system for your email to categorize your incoming emails into spam and not spam, right? And you don't have enough data, to train your model.
Right.
So in order to train a model, you usually have to have some kind of data, plus we call it target value or label.
Okay.
So let's say you have an email from some king from Nigeria, and then that is like spam. Right. If it's spam, you put it like spam.
Right.
And
unless you happen to be friends with the king from
Nigeria.
Exactly.
Or there's another email from a friend, and you don't want to classify it as a spam, right? So you have to have like not spam.
Okay.
So Mechanical Turks are sometimes in a training we use people's help basically to label the data.
Right.
So they will read or they will like understand the image, or if it's a video, they'll watch the video and say, okay, this is good video, this is bad video, this is good, this is bad, etc. And then that data is given to the model so that it can learn. And then whenever new data comes in, it will say, oh, this is bad, this is good, this is bad, this is good, this is spam, this is not spam.
I see. So just to clarify, could you quickly explain what a Mechanical Turk is?
Okay, yeah, that's a good point.
Yeah.
Maybe our understanding might be different. But in my understanding, I've never used the service. But in my understanding, it's like basically you ask the crowd to help you to In machine learning space, basically, sometimes when we need more data to train our model, you might ask like the crowd to help you to build the labels for your data set.
I see.
Yeah.
So these are actual people.
Actual people.
That are going through lots of different, perhaps images or
videos
text
or
videos,
yeah.
and labeling them.
Yes.
And then so these people are called mechanical Turks. And then that is done, if I'm not mistaken, to a point where you have a large enough data set to hand to a computer with an algorithm for them to take over.
Yeah.
How large does that data set need to be?
It depends on the problem.
Yeah. So let's take the YouTube problem. So for or the instance of recommending a video to you, how many data points would it need before it can start doing the work on its own and successfully recommend something useful to you?
So I didn't really work on the YouTube recommendation originally, so I can't really tell like how much data you would need. But there are different systems that might also help you to collect enough data. For example, one system would be just basically, if it's in case of video, you might get the video and then slice every frame. So in one video you have in 1 second you have around 24 frames.
Right.
If it's a video, right? Frames of images. So you have to slice that and understand each frame, what's happening inside. So there are systems that help you to extract what are the objects within the video. So you might basically use combination of different technologies plus Mechanical Turk to collect the data or to have to prepare the data for your model to be trained on.
I see.
So it really depends on the problem. And for YouTube, I don't really have the clear-cut answer because it's like a very huge system.
Right.
And
so it sounds like for a system like this, it does require humans in the beginning to help out the machines before they begin learning.
Yeah, in most of the cases, you need human beings to label the data.
I see.
But I think currently there are already pretty well-trained models that do that kind of job automatically. So most of the job of manual labeling is taken over by certain machine learning models already.
Right.
That have already that knowledge. And then you use that data to train another model for your own purpose, like business purpose or whatever purpose,
Wow. I see. When I was, you shared some links and videos that I was watching, and they cited Google Translation Overlay as an example of machine learning. Can you quickly explain what that product is?
Google Translation Overlay.
Yeah. The video or the image I saw was it was an app on a phone that you hovered over a language that you didn't understand and then replaced it with a language you know. What exactly is going on there from a machine learning point of view?
Yes. There's a lot of things going on there. Again, I didn't really look up into details of that technology, but I can basically speculate.
Please. Yeah.
So whenever you pick up your phone and there's unknown word, unknown sign when you're traveling, you just direct your camera towards that sign and then it tries to translate automatically for you, right?
Right.
So what's happening is that first thing is that camera basically captures the image, and then I think currently maybe model exists within your phone, so it doesn't send the image back to the server.
Okay, so no internet connection is required.
Most probably, but I'm speculating here.
Okay.
It captures the image, and then it tries to extract the text from the sign.
Okay.
Okay. And then it extracts the sign and then passes over to Google Translate. It translates, sends back the data to your phone, and then it tries to regenerate that kind of area of the sign on the fly so it can overlay the text on the top of original text.
Oh, I see.
Yeah, and that's happening within the fraction of milliseconds.
Milliseconds.
So our eyes are not able to detect.
Wow. One of the most interesting parts of that to me is the way that the computer is able to detect the written word on the screen. And one of the videos you shared with me showed exactly how a computer would be doing that, taking basically how dark a pixel was within a certain area. And that, can you briefly kind of go into that a bit?
So that's called, I think currently most people use, maybe I'll step back.
Okay.
So there's different different fields within machine learning. So basically, in my understanding, what we're trying to do is simulate human senses.
Right.
Computer vision is basically human vision, trying to make computers see.
Okay. Yeah.
There's speech recognition, trying to basically creating kind of ears for computers so they can understand us, human beings.
Right.
That's called like speech recognition, let's say. And then there is vision. We talked speech, natural language understanding, right? Which is basically whatever you say, it should understand your speech and try to translate to whichever language you choose.
Right.
Right. That's also difficult. Or summarize whatever you say or whatever text you give.
Right.
That's natural language. So the one that you just the question that you asked is related to computer vision, basically, and then so within, as you remember, we've talked AI, machine learning, and deep learning. So within deep learning, there are like different subsets as well, and one is dealing with computer vision.
Okay, wow, that's its whole division.
Yeah,
computer vision.
Yeah, computer vision is total on its own a division.
Wow. Okay.
And there are like many researchers on this field, just on this field. So people currently employing a framework or approach called convolutional neural networks.
Okay.
So what it does is basically tries to understand image and classify to based on your objective. Okay. So, for example, if you want to understand handwritten digits, which you are giving an example, right?
Yeah.
So imagine you have a very small image of somebody's handwritten digit, and you just pass over to computer machine learning model, and then it should predict or it should tell which number it sees from the given image.
From that given image.
Yes. So let's say you've written 4. And then computer, when it reads, it doesn't know if it's 4 or not because it just gets like a bunch of numbers.
Right, the raw information.
Raw information. And then if you're giving as an image to computer, then image should be converted into numbers.
Right.
And in computer, image is represented as a pixel values, right? So for example, let's say you have an image of like 10 pixels by 10 pixels. 10 pixel height, 10 pixel width. Does it make sense?
Yeah. So we have about 100 pixels, right?
Yes.
Yeah.
And then within that box or frame, you've written 1, right? And then imagine the frame itself is black, and you have a chalk, and you're writing with white. Okay. Now we take the picture of this frame and pass over to computer, and how computer sees it. So the black dots are represented with values 0. 0 meaning like completely black dots.
Okay.
Each pixel is black dot.
Okay.
And then depending on luminosity of the color on the image, this number changes from 0 to 255. 255 is complete white.
Oh, okay.
0 is complete black. And in between you have like grayish colors.
Right.
All right. Now, if it's black and white, then it's just one kind of frame. But if it's colorful image, then you have 3 channels: red, green, and blue.
This is the RGB color.
RGB colors, yes. And then you have to combine that data and then pass over to your model. And then what computer sees is just a bunch of numbers from 0 to 255.
Right.
So based on those values and the position on the image, it tries to learn what is actually represented within that image.
I see.
Does it make sense?
It does. And a part of the machine learning is that when it's trying to recognize a handwritten number, everyone's handwriting is different. Even the same person from one number to the next will look different. So they're learning generalizations? Yes. So how the generalization happens is that here, very important point is how you collect the data and what kind of data you have. So in this field, computer vision, the most commonly used data set for testing and prototyping purposes is called MNIST. MNIST. I don't know what it stands for. I forgot. But it's basically a collection of handwritten digits from pretty large population in U.S. Okay. From like young kids to adults. Okay. And there's like different kinds of 2s, different kinds of 1s, and different kinds of 0s, etc., etc. All right. So you give this bunch of numbers. I think it was around 60,000 different types of 1s, let's say. Oh, wow. Oh, not 1s. Maybe there are 10 classes or 10 digits. So each digit might have over
1,000 or 2,000 different variations.
Different variations. So this is the data set, if you will, that they're working with. Okay.
And then that data set has like, this is the image of one.
Mm-hmm.
And then on the next, let's say, column, if you just imagine there's an Excel sheet.
Uh-huh.
One cell is like your image. Mm-hmm. And another cell you say, okay, this one is one, real one.
Right.
Like just a digit. And then you pass over to machine learning model. Mm-hmm. And then it will try to basically learn if it's one that matches the output, the real one or not.
And what they're actually matching is which parts, the color codes per pixel.
Yes, that's one thing. Another thing is basically in the convolutional neural networks, we call there's a thing called filters.
Okay.
Or kernels. Those filters, they try to identify the edges shapes. So for example, one will have completely, of course, different shape than two. Right? So like the way the strokes like move around.
Right, yeah.
So these filters, there's like maybe you can set like how many filters you want to have, like hundreds of filters. Right. And each filter represents like different shapes. It will extract different shapes.
Oh, I see.
And then it will train. So what is training? Basically, you just give the input, neural network. The data, the numbers basically pass through the neural network. And there's like algorithms, tiny algorithms basically calculating, doing like addition, multiplication, and all this stuff together. They go through this neural network. And then there's going to be an output saying, oh, this image you gave me is one. And then there's a real output, which is one, let's say. And it compares. And if it's one, then it learned. If it's not one, then it goes back again, picks up another image, tries to learn, comes back and says, okay, maybe it's two, but the actual value is one, let's say. It just goes through like thousands of iterations over the data.
Right.
And then tries to generalize.
I see. And so when you say it's learning, it will, if it comes to a wrong conclusion, it will remember that conclusion was wrong.
Yes.
And never make that same mistake again.
It will try.
It will try.
Yes. And then, so that's called loss, we say.
Okay, loss.
Loss. So loss meaning, let's say you predicted 2, your model predicted 2, but actual value was 1. Then
that's a loss.
That's a loss. So you're losing, basically. It's not correct.
I see.
And then if the loss is big, let's say you completely randomly predicted something.
Right, like rabbit.
Yeah, whatever. And then there's a completely different prediction, then the loss is big. And then the algorithm basically would say to itself, okay, I'm completely wrong. I should go back, pick up some more batch of data, learn some more features, learn some more shapes, and then try to predict, compare. If it's wrong, go back, compare, go back, train, go back, etc. And then at the end, there's going to be like, so you have a measurement which basically says how much your prediction is accurate. So initially it might be like 30% you're accurate, then 40%, 50%, 60%. At the end, when you reach 99%, you're done.
You're done. So the computer is pretty positive. If it's wrong, it goes back, it learns some more.
Of course.
Right. That's great. Yeah.
That's what it does.
Yeah. Okay. This is, so for a lot of people, they're one of the banes of their existence on the internet is filling out those Captcha forms, where they have to look at an image and write in the text and letters and what have you. And I think this is for websites to prevent, I guess, hacking computers or spamming computers, making fake accounts. If computers can now do this, is that still working? Is that relevant?
Yeah, when I started learning about computer vision, that was my question as well.
Oh, really? Okay.
The Captcha still exists because computers can't solve all the problems.
I see.
So, for example, whenever you see a Captcha, it's pretty distorted sometimes. Like there's like very noisy images sometimes, very blurred, very noisy. Right?
I often get them wrong.
Yeah. Human beings are if human beings are getting wrong, then for computer it should be even harder.
Right. Yeah.
So there are some areas where computer vision or machine learning cannot do pretty well.
Do that. Yeah.
But currently, I think it's amazing that how it basically it learns and then tries to basically match the human level accuracy in most of the tasks. But there are certain areas, like you said, the Captcha, for example, where you have very noisy data. Then it cannot basically do the same job as human beings doing.
Right. That ties into my next question, which is about where are the biggest challenges right now in machine learning? Is it in having enough data sets? Is it computing power? Is it just, or is there some other difficulty?
Yeah, everything basically you said.
Everything, all of the above.
So what's happening now is, I mean, in my basic day-to-day job, what I find challenging is infrastructure is there, but it's still hard for newcomers to quickly do machine learning. So because you need to first get your data, clean it up, and then cleaning, data pre-processing takes most of your time, almost 70% of your time.
Really, just getting the data to a point that it's useful.
Useful.
Wow.
Because you have to also have a good data set where it basically helps the machine learning algorithm to learn. If you pass like completely gibberish data, then it can't learn anything.
Right, it won't achieve.
Yes. Okay. Plus, there is a term called data imbalance. Sometimes you might have like many positive values than negative. For example, in case of spam, you might have many not spam data comparing to like very few spam data.
I see.
And then for machine learning, it's going to be hard to learn from this kind of imbalanced data set.
I see. It's like in statistics, if you just fed the computer all outliers.
Yeah.
Right. Then they can't do anything useful with that.
Yeah. So infrastructure-wise, it's a bit basically, it's getting easier and easier day by day, but it's not super easy to get through this kind of data preparation and building infrastructure around data easily done. So that's one thing. Another thing is for neural networks, we still a lot of data, I guess. So there are many researchers working around basically being able to train models with few data. So you don't have to collect a lot of data to make your machine learning model to learn. So that's what is happening. And machine learning itself is very, very broad and deep ocean.
Yeah.
So sometimes you just get basically overwhelmed. And there are so many tools. Some of them are super complicated. Some of them are not. So initially when I was basically getting into this field, I found it really hard to pick up the tool and get used to, quickly build the models that I want.
Right.
So I spent a lot of time just learning the tools, not the theoretical concept around machine learning.
And when you say tools, you mean software?
Yes, software.
Okay. Yeah, that's a good segue. What kind of software and hardware are you using? For example, when you're gathering the data for the computer, are you just putting this all in a Google sheet and just feeding it to the machine? Like, how does this work?
Yeah. I wish it was that easy.
Yeah.
So what happens is that we use different languages, programming languages, to do. We say it modeling when you build the model.
Okay.
So there are, but I think currently most people are using a language called Python.
Python.
Yes, which is scripting language, dynamic language, which allows you to quickly build your models. Mm-hmm. And you could also use C++ as a language to build your models, but it would take more time to develop because you have to write more code.
I see.
And it's harder. As for data, since we'll usually have a lot of data, you can't really store everything in your Excel or Google Sheets. So you should have some kind of database.
Okay.
Or you can just save all the files into your computer and write a program to read it and pass over to your model.
Okay.
So that's another thing. And for hardware, if the model is very simple, then you can use your laptop.
Oh, really?
If the data is not that huge.
And when you say simple, what's the simple problem for machine learning to solve that you can run from your laptop?
For example, linear regression, let's say, which is basically, how do I explain it?
Well, what would be a real life use of linear regression?
Regression, let's say you want to predict your sales. Okay. So you have existing data from your let's say 1 year's data, and you spend you spend money on different ads like online ads, TV ads, newspaper ads, etc., etc. And then based on that, you are basically trying to predict how much value or how much return on investment you will have if you spend this much money on online, this much money on TV, this much money on newspaper advertisement, let's say.
I see.
And then you just build this kind of a correlational model where you say, okay, if I spend this much, then how much it's going to increase or decrease.
Oh, I see.
Okay, so it's just trying to predict the value of like return on investment.
I see.
Yeah.
So high school students could do this, like how much time they spend studying English versus math, and then how well they'll do on the SAT.
Absolutely.
As a result.
Absolutely, yes. If they have a data about like previous students, let's say how much time they spend on math or like whatever subjects are required for SAT, let's say, and then like for previous year, they can use that data to build this kind of regression model. Let's say if they spend this much time on math, English, physics, chemistry, whatever, then how much score they might have in the future whenever they take a test.
That sounds like a very involved way to figure out that. They'd probably be better to spend the time studying for the test. Okay, you mentioned neural networks briefly, and if I'm not mistaken from what you sent me, neural networks try to mimic the human brain in order to achieve deeper levels of machine learning. Can you talk a little bit about that?
Yes. So there's also like a debate around in between neuroscientists and computer scientists whether it's okay to use neural networks as a term because it's basically coming from neuroscience, I guess.
Okay.
But what deep learning or neural networks is trying to do is basically emulate, I guess, the simplest functions of our brain. So the way you structure your model is basically you build kind of a. So let me just step back again.
Sure.
So I did also do some small research on brain as well. I mean, I'm not a neuroscientist, but I have personal interest. So in my understanding, our brain basically contains around from 85 billion to 100 billion neurons.
Okay.
Tiny cells, let's say.
That's a lot of neurons.
A lot of neurons. And each of them basically does a calculation. So whatever you see, whatever you hear, whatever you feel is basically passing through that information is passing through through those neurons. And then they do calculation, pass over data to the next neuron, and the next neuron pass over data to the calculation output to the next one, et cetera, et cetera. That way your neurons are connected to each other.
Oh, okay.
So, and the way they work is basically there's, I'll try to show here, but I guess our listeners won't be able to see.
Well, maybe afterwards we can upload some images to help them.
Sure, yeah. So basically neurons, in a simplest structure, it has basically one input branch.
Okay.
So the neuron is kind of, it's a round thing and it has branches.
Okay.
And one of the branches basically reads the data or reads the information, gets the information from other neurons. Another branch passes over the calculation that happened in this round cell to the other neuron.
To the other neuron.
Yeah. So I'm just basically, it might not be round.
right.
But just like
visually.
Visualize it. Yeah. So, and the branch that collects the data is called dendrites, and the branch that passes data to the other neurons is called axons.
Okay.
Okay.
These are familiar terms from biology class.
Exactly. Yeah. And then each neuron is connected to other neurons in several ways. And then whenever they get the input from the previous neuron, they do a certain kind of calculation, a biological calculation. And then if the calculation output reaches certain threshold, then they will spike and send the information to the next one.
I see.
If it doesn't reach certain threshold, they wouldn't spike and the information gets deleted.
And when you say threshold,
yeah,
what do you mean by that?
Threshold, so it's I guess there's a lot of biochemistry things happening inside the neuron.
Okay.
So they just release some kind of chemical elements.
Okay.
And that helps the axon to get the neuron to get excited and pass the data or information to the next neuron.
I see.
And then, so why I'm talking about this, because neural networks work in a similar way.
Oh, okay.
Yeah. So
Going back to the chemical, you mean if we're looking at something that's dangerous, right? The information would be received by the dendrites to one neuron, conduct an algorithm, and perhaps come up with the conclusion that this is dangerous.
Yeah.
And then release a chemical, perhaps adrenaline.
Yeah.
And then send that through the axons to another neuron, so on and so forth, until the biological being is set to run, like run away.
Exactly.
Okay.
Exactly.
All right. And now from the computer's point of view.
Similar thing is happening, but not exactly similar thing because the computer, the architecture and the way they do the calculation and the way basically it works completely different, I guess, compared to our brain. But the idea is similar. So the neurons also have like input branches and then output branches. And within each neuron, there's kind of a small algorithm working. Basically, whenever new data comes in, it does certain calculation, and then there's a threshold. If the calculation output reaches certain threshold, it passes or gets excited and then moves the data to the next neuron.
I see. So
and then next neuron picks it up, does its own calculation, moves the data to the next neuron. And that way you connect like different layers of neurons, the same way as human brains, neurons are connected.
I see.
And then at the end you have the output if it's number 1, number 2, number 3, etc.
Right. So for going back to the example of recognizing handwritten numbers, if the computer senses visually perhaps something that is kind of like a loop, right, like a circle and a number, it would then send that information to the next set of neurons that says, oh, because there's a circle here, it could be a 6 or a 9 or an 8, but it's not a 4. And so it would send that information to the 6, 8, or 9 camp, and then it would say, oh, well, actually, there's two things that look like loops, and so this is probably not a 6 or a 9, but it could be an 8.
Yep.
And so on and so forth.
Yeah. So in a simplest form, so when you build a neural network or like a structure to build your model, what happens is you have an input function, we call it, which reads your images and passes the data to neurons in terms of like numbers, right? So what happens is that it passes the number to the first layer, and you might have like 1,000 neurons, let's say. And then each neuron is basically reading out the data from your image, right? And then there are algorithm that calculates, and it basically what calculation is trying to extract the features, like different shapes. And then you have like different layers connected to each other. And when you reach certain level, the output at the end, what it sees is basically instead of shapes, it sees like bigger picture.
Oh, okay.
Know what I mean? So it basically, you see like smaller shapes, smaller features. Move on to the next one, it sees bigger shapes, bigger kind of picture. And then when you reach the output, it kind of sees what exactly in the image.
Right, and then make its
own decision saying, okay, this is digit 1, this is digit 2, this is cat, or this is dog kind of thing.
So this neural network that you're describing, the handwritten number is, it's not, I don't want to call it simple, but in terms of its output, yes, it's simply saying a number. What would a complex problem look like that this same process would try and solve?
I mean, image understanding itself, I guess, was a complex problem up to 2013, I guess, overall. Yeah, because in handwritten digit recognition, you have only 2 colors, black and white.
Right.
Right. But when you take a real image with your phone or with your like camera, the world is messy. You have like tons of colors, tons of shapes, tons of different kinds of animals, objects, etc., etc. So you have like not infinite, but vast variety of different objects.
Right.
And for a computer to figure out what object belongs to which class is very, very hard.
It needs a lot of data.
A lot of data.
Yeah.
Yes, and there was a big, I think, collection of good data set from, I guess, Stanford University, which had like basically the this kind of complicated image of like different objects: cats, dogs, human beings, baseball, bus, rockets, whatever. And then each of them had the label. So what is inside the image?
Oh, okay.
And then we passed to the computer, to the model. It learned from this vast amount of like information, and now it somehow can understand different objects within the image.
Wow.
Yeah, so you might have like different kinds of data sets in terms of, for example, for computer vision. And each problem, like if the image contains very unseen data, let's say, then it's going to be hard for a computer to be able to predict.
I see.
So there was a research around, I think, maybe last year, I don't remember, but there was a astronomers actually found new solar system kind of I wouldn't say solar system, but a system that's like similar to our solar system.
Okay.
Which is like, I think, 2,500 light years away from our solar system,
right, yeah.
Using machine learning, basically, because they passed the data taken from Kepler telescope.
Right.
And then it has tons of like different kinds of data, right? Like the star systems. And then machine learning was basically able to recognize different patterns and be able to detect.
Wow.
And then they discovered.
That's amazing.
That's amazing.
Yeah, that is pretty incredible.
Yeah, and for human beings, I guess it's pretty hard to do these kind of problems because we have to analyze vast amount of data, and our brain is not capable of doing that.
Right.
But machines can do that. So
easily. Wow. So you work in this field. What kind of projects are you currently working on that you can tell us about?
So I have only 2 projects for now.
Okay.
Yeah, pretty interesting. One is basically I do predictive models.
Predictive models.
Yes. I can't tell all the details,
Okay.
but the general idea is basically be able to predict if user is going to sign up to your website, or if the user is going to churn out, or if the user is going to buy, or user's behavior, basically.
User's behavior.
Yeah.
I see. That is a very useful thing to know, how people are going to behave. I see.
And the second one is I teach machine learning internally.
Oh, okay,
I have
great.
some classes.
Yeah. So I'm curious about that because you just got into machine learning recently.
Yeah.
And it isn't exactly your background, and now you're at the point where you're teaching other people about it. What types of skills are needed to get into machine learning? Because from the small amounts of research that I've done, it kind of seems like it involves a lot of math, a lot of hard science.
Skills. I guess the biggest skill is, it's not a skill, but I guess the aptitude, like curiosity.
Oh, okay.
So if you are curious enough and you have patience, then I think you can conquer machine learning and AI.
Yeah.
But if speaking seriously, then I think the skill set, the kind of a basic skill set that is required is, I think it's like I don't know in U.S. education how you do it, but I guess maybe not super advanced mathematics.
Okay.
So just certain branches of mathematics you should be kind of aware of, like linear algebra,
Okay.
And then statistics, probability, like basics of probability.
Okay.
Information theory, which is not that also super difficult. Basics. You don't have to go too advanced into these topics.
Right.
And then for programming languages, I think for now it's very commonly used Python.
Okay. I was surprised to hear you mention C++. Because when I was in middle school, we were learning C++ back then, and so I would think that we would have that language would have been buried in the dustbin of technology.
No, it's still big.
Yeah.
All the systems are being built with C++.
Wow. Okay.
Yeah. So I guess those are the skills, and you don't really have to have super. You don't have to be super good at these kind of things. People sometimes say, "Oh, you should be very good or talented in math or talented in physics," but I feel like there are so many people who are self-taught.
Oh, really?
Yeah, self-taught. Basically, they taught themselves mathematics and computer science on their own because the field of AI and machine learning is so exciting. It can solve so many problems. So they just spend some time to basically catch up with that.
I see.
And that actually happened to me. So I'm still learning mathematics and computer science, but still, I think it's not impossible thing for many people.
Right. So you're learning as you do the work.
As I do the work and as a hobby, basically, I like it.
I see. Before we started recording, you mentioned something about how the field of AI and machine learning has exploded in recent years with attendance in worldwide conferences. First, can you speak a little bit about these worldwide conferences and give an idea about how new and fast-growing this industry is?
Yes. So there are several important conferences in different fields of AI, like computer vision, natural language processing, speech processing, etc., etc. And I think, I didn't really looked up the statistics, but from my basically friends' Twitter feeds or talking to AI experts, I always hear that the applications to these conferences are increasing a lot, and there's not enough people to review the papers to accept into the conference.
Oh, wow.
Basically. And it's getting harder and harder to get into the conferences because so many people are interested in doing machine learning.
Sounds like you can get a machine to go through those applications.
Yes, exactly. There's actually one team and one startup, I think, working on that. Basically
really?
Reading the papers and basically judging.
Wow, that's
So yeah, it's very exciting area, and there are companies that are dedicating their resources to educate as many people as possible, because we need a lot of people with diverse backgrounds, not only like computer scientists or mathematicians or like physicists, but like people from social sciences, medical sciences, even like politics or economics, whatever. So they will have different kind of perspectives of solving this problem using machine learning.
I see.
And there are companies like Fast AI, for example. They're developing different kinds of software and frameworks to make easy for people to implement machine learning algorithms quickly without spending time to learn, the language itself or the software itself.
Right. Like nowadays, you can make a website with a drag and drop
Yes.
online service. You don't need to know HTML or JavaScript.
Yes. I mean, Google offers and Amazon offers this kind of tools where you don't have to write like a lot of code, but they're kind of pre-built models, so you can't. They're not super flexible.
I see.
You can basically get most of what you want, but if you want to train your model to identify very niche, let's say images or like niche text that this big model's never seen, then they don't really perform well. But for that, you need to train your own models. So some of these companies are basically providing you with very user-friendly.
Right, out of the box,
Yeah.
able to be used.
Yeah, so you just write several lines of code and you will be able to train your model and deploy it and use it for your business or personal purposes.
Wow. I want you to put on your fortune-telling hat right now. And
Okay.
how long do you think it will be until we get to a point where computers are able to tackle most of these tasks better than humans?
This is very difficult question. And
Yeah,
I think
I promise that I will not hold you to this.
Sure. Some of the experts are very, very optimistic about this. And they say maybe by 2045 or 2035 we'll be there. Like we'll have generally artificial intelligence, which will be like learning and doing things like human beings. Some experts in this field are pretty pessimistic, saying like it might need centuries, maybe.
Centuries, wow.
Yeah, centuries. Personally, I feel it might take longer time, which I'm not sure how many years.
Longer than the optimistic?
Longer than optimistic,
Okay.
definitely, yeah. But I think currently computers are, like these kind of machine learning models, are getting better at certain tasks better than human beings. Like, let's say, a certain image recognition or language understanding. I mean, language understanding is still humans' domain, but some like
Right.
specified machine learning models are like better than human beings. So like kind of specialized areas are, machine is basically taking over. For example, game of Go,
Oh, yeah.
right? The champions were basically beaten by machine, which, most of the AI experts thought that machine won't be able to beat human beings in this kind of intuition-based games, but
Right.
now it's there.
Right.
So we don't know like when it's going to happen, but I mean, I'm pretty optimistic about machine learning and AI stuff, and it's going to impact. I think it's going to have really good impact, positive impact on our society, in case if we build it in the right way. So it's like nuclear bomb maybe like it has like nuclear energy, right?
Right, harnessing the energy could be used for good.
For good and for bad.
bad.
Yeah. So in AI, I think it might be kind of the same depending on who controls.
Right.
How it's developed, what purpose.
And right now, is there a worldwide governing body to kind of control how it's being used?
There is, to my knowledge, I think there is one organization, maybe OpenAI is called.
OpenAI?
Most probably, yeah.
Okay.
Yeah, I'm not 100% sure, but I think that organization is trying to bring into the same table everyone, basically to governing. But there are many different conferences basically where also people discuss, challenge each other, and help each other basically to tackle certain problems in a right way.
Right.
And in many organizations and like private companies as well as like big public companies, I think people are working on a kind of a new area of machine learning called machine learning fairness.
Fairness, okay.
So what it is so the model you train is basically based on the data you give.
Okay.
So if data is kind of imbalanced, if data is basically biased towards certain, let's say, race, or towards certain kind of group of communities, people, language, etc., then it's not model's fault. It's our fault that how we're providing the data.
I see.
So there is another research area where people are tackling this preparing data, cleaning it up, making more objective before machine learns.
I see.
Because machine is basically like a child. It learns whatever you give or whatever you tell it.
Wow.
So that area is also kind of, I think, is pretty actively being researched at this moment. And that also helps to kind of steer building good systems that does not damage environment or human beings or...
Right, yeah. That's a very important topic there.
Yeah.
And one of the last things I want to touch on is this idea of ultra-intelligent computers.
Mm-hmm.
And from what I've read, the idea is that computers will become intelligent to the point where they can upgrade themselves without the need for humans.
Mm-hmm.
And then some people say that it is at that point that the computers will no longer need the humans to continue to thrive, right? And I'm not talking about like robots running around and causing mayhem. But do you see that as being potentially humanity's last invention? Like once the computers can improve themselves and then they themselves can solve the problems that we have. What is that kind of the end?
I agree with the scientists who say like AI might be the last invention of human beings.
You do?
Okay. I agree, but we're not there yet.
Right.
I think if people are interested in this topic, then I think one of the good books that I can recommend is Superintelligence by Nick Bostrom.
Okay.
It explores this idea about how a machine might damage if we lose control of it, basically.
Right.
So that's really good kind of a research and discussion into this topic.
Mm-hmm.
But I mean, machines are getting more and more intelligent, but there's still like a lot of human work involved in it.
Right.
And so machines basically learn something, but they can't do anything on their own unless human beings say to do something.
I see.
They can predict number like digit, but what's the value of it?
Right, yeah.
That's like us human beings basically using the value at the end.
I see, okay.
So
to that end, it's still a tool.
It's a tool, yeah. And I view it as a kind of a augmentation of human intelligence.
Oh.
Because our brain inherently is not able to process a lot of information at the same time. We need time. And we need like pieces and like of information to process, understand, and then do something with it, right?
That's a fascinating way to look at it.
Yeah.
Perhaps, continue.
Yeah, and then in my view, AI, what it does is basically it helps us to understand more data if it's built properly.
Right.
And then it helps us to make better decisions than if we do it on our own, just relying on our intuition. Right. So it'll have like, I guess, better understanding of the let's say, reality or the problem that we're trying to solve.
Right.
So in that case, in that sense, I see it as a TARS, the robot in Interstellar.
Yes.
That clunky robot.
Right. Yeah.
So I watched that movie a couple of times and always think like there's very good collaboration between that AI and the human being in that movie.
There is, yeah.
So do you remember there's a moment where what was his name, the main character? I forgot.
I can't recall.
Okay.
Well,
But in any case, so there's like kind of a accident happens in the spaceship, and then they have to dock into another one, and then that the ship is rotating like crazily.
oh, right. I remember this scene.
Remember that? And then human being is not able to calculate what's the spin rate.
Right.
And it asks, hey, TARS, like, can you calculate it? And I'm going to dock it.
Right. Oh,
And it does
I
a
see.
calculation, but human beings steer it
I
and dock
see.
it. But if there was no TARS, then human beings would die. If there was no human being, then TARS would die.
I see.
So there's a good collaboration happening. And that's what I see AI helping us to basically tackle unsolvable problems that we cannot solve on our own and help us basically to advance further the civilization.
That is amazing. It almost seems like we should name AI to be augmented intelligence as opposed to artificial intelligence.
I think there's also a kind of a branch of or like group of people who view it in this way.
Oh, is there really?
Yeah, so it's kind of it is artificial intelligence, but kind of augmenting our own intelligence.
Wow.
Because we understand many things, things better than before. And one more thing that I'm super excited about it is that I think people are slowly start using it to do like scientific inventions, let's say. Like, for example, finding the star system was one of the examples.
Right.
And then there is another example. I think I was in a lecture by a Stanford professor, and he was saying interesting thing about so there's when you test a computer for intelligence, there's a test called Turing test.
The Turing test, yes.
You've heard about it?
Yes.
Right. Okay. And he
for some listeners who may not know, could you explain what the Turing test is?
In its simplest form, it is like basically you make or like you ask somebody to talk to a computer, and then if the person talking to that system or computer or machine, whatever, thinks that he or she is talking to a person, then
they have passed the Turing test.
They pass the Turing test, basically. Now I think computers are basically trying to do that, and we're getting closer to that. I mean, in terms of like, let's say, the way they understand our speech. You speak and it can basically translate it without you typing it. It's pretty good. And the professor was saying, like, instead of testing for Turing, what if we test for scientific invention? If computer can come up with the invention of like some kind of scientific invention that human beings never thought of, then it might pass another level of intelligence test.
Right, yeah. And that may even be more useful.
Absolutely, yeah.
A computer, talking to me about what it ate for breakfast is not as helpful as finding a new system of stars.
Yeah, absolutely. And there's one, he gave an example of a software called Atom to Vec.
Atom to Vec.
Yes, basically atom to vector.
Okay.
Vector is a kind of a representation of numbers that you pass over to machine. So the idea there is, again, one step back. So there's a thing called software called Word to Vec.
Word to Vec. Okay.
Which basically helps you to build a model to understand human language. So it represents each word or each character with certain kind of numbers. So you convert each letter or each word or each sentence into certain kind of numbers, and machine learns the sentence representation. It tries to understand the sentence. So they applied the same idea to periodic table of, what is it, chemistry?
Elements, yeah.
Elements,
chemistry,
yeah. So what they done is like basically they created this data of like elements, like randomly, like say randomized, let's say, and then you pass over to a model. It learns, trains, and then it organizes the information, and it created this periodic table on its own.
Really?
Yes. Basically, it invented, let's say, the periodic table that Mendeleev did like long time ago.
Right.
And it took for a long time. I mean, it took like for Mendeleev, like I guess years of
Right.
like researching around it. But for machine, it took maybe like, I don't know, depending on the compute power, it may take like several hours or several days.
Right, yeah.
So that's also getting possible.
So really the limits of machine learning are the limits of human creativity.
Exactly.
To come up with the right data sets to answer the right questions.
Yes, right data sets and the right sets of algorithms to answer the scientific question, business question, or creativity question, or whatever question you have.
Wow.
So it's a pretty powerful tool to solve many problems.
Sounds like it. For someone who is just learning about this for the first time, or for younger listeners as well, this could seem vastly overwhelming. Where would someone, say in junior high school or high school, start if they wanted to learn more about this? How you said they could learn a lot on their own. Where should they go?
Internet is my recommendation, I guess. Yeah. There are many sources, like resources available on YouTube, Coursera. There's a kind of a website called Coursera, which provides like different courses on different subjects. So they also provide from beginner's level up to advanced level machine learning courses, which includes both programming, mathematics, and data cleaning, data preparation, basically all the steps.
Okay, wow.
That's one thing. Another one is they can go to I'll advertise Fast AI.
Fast AI, okay.
I'm not affiliated with Fast AI, but I think they're doing a really good job, so they can go and then check it out. They also provide like free resources.
Oh, wow.
So they do online teaching. They provide all the resources for free, so they can check that out as well. And there are so many books, but I would say don't get overwhelmed. Just try to pick one topic within this vast environment, just the one that you are interested in.
Mm-hmm.
Either it's like natural language understanding, or computer vision, which tries to understand the images, or speech synthesis, like basically recognizing human voice, that kind of stuff, and then go deeper into it.
Wow.
And yeah.
This is great. For those of you listening, I will link to all of those in the show notes so that you can access them.
Yeah.
This has been a very fascinating conversation, especially because I think for most of us, machine learning is something that was not on our radar. And it, for me, at least personally, it gave me a little bit more of a concrete way to look and think about this big topic called artificial intelligence that gets thrown around a lot in the news nowadays.
Yeah, absolutely. Yeah. It's everywhere.
That's great. Well, Azamat, won't take any more of your time today. Thank you so much for coming in and having a chat with us.
Yeah, thank you for having me. It was great.
Appreciate it.
Thanks.
All right, and there you have it. Thank you, everyone, for listening today. I'd love to hear from you, so please send your comments, thoughts, or questions, or just say hi at hello@inspiretokyo.com. If you enjoyed what you heard today, please share it with a friend. We are always looking for new listeners. And be sure to subscribe to us wherever you listen to your podcasts. See you next time.